Hello students, welcome to a series of mathematics program for grades 10 and 11. The topic for today is trigonometry. This is the second lesson on trigonometry. In today's lesson, you will learn about the sine rule. The prior knowledge for today's lesson, you will need to recall what is a right angle triangle, the Pythagoras theorem, and the trigonometric ratios. So in the previous lesson, you have learned about the Pythagoras theorem and the trigonometric ratios. So remember, opposite the 90 degrees, we have the longest side, which is called the hypotenuse. And the Pythagoras theorem states that the longest side, that is c square, will be equal to a square plus b square. Now, given the angle x, opposite to it, we have the opposite. The longest side is called the hypotenuse, and the remaining side is called the adjacent. Using the acronym SOHCAHTOA, I will have the three formulae: sine x equal to opposite over hypotenuse, cos x equal to adjacent over hypotenuse, and tan x equal to opposite over adjacent. So these were what we had learned in the first lesson. In today's lesson, we will learn about the sine rule. What is different is that for sine rule, and yes, the cosine rule also exists. So for sine rule and cosine rule, we do not use the right angle triangle. So suppose I have triangle ABC. Now, opposite to the capital letter A, opposite to angle A, I will have small letter A. Opposite to capital B, I will have a small letter B. Opposite to capital C, I will have a small letter C. So here, small letters A, B, C will denote the length, and capital letters A, B, C will denote the angles. The sine rule is as follows: A over sine of angle A equal to B over sine of angle B equal to C over sine of angle C. Or I can also write it as follows: sine of angle A over A equal to sine of angle B over B equal to sine of angle C over C. Remember, the small letters A, B, and C denote the length. So we can use the sine rule to solve triangles when, firstly, two angles and a side are given. Secondly, two sides and an angle opposite a given side are given. So we have two cases where the sine rule can be used. Firstly, you know two angles and one side. Secondly, you know two sides and an angle opposite one of the given sides. The following are important when solving a triangle. Remember, solving a triangle means finding the remaining sides and remaining angles. Firstly, in any triangle, the sum of the three angles is 180 degrees. Secondly, the shortest side is found opposite the smallest angle. So in any triangle, the shortest side is found opposite the smallest angle, and the longest side is found opposite the largest angle. Thirdly, a triangle can be constructed only if the sum of the length of the two shortest sides is greater than the third side. And lastly, if you're only given three angles, you cannot obtain a definite solution. Let us look at case 1. 2 angles and one side given. First example, solve the triangle ABC in which angle A is 70 degrees, angle B is 45 degrees and AB is 8 centimeters. So I need to solve the triangle ABC. The first step will be to find angle C. So remember the sum of angles is 180 degrees. So to find angle C, it will be 180 degrees minus 70 plus 45. So angle C will be 65 degrees. The next step will be to label the sides of the triangle. So opposite to capital C, I will have small c. Opposite to capital A, I will have small a. And opposite to capital B, I will have small b. I now write down my formula. I replace what is known from the triangle. So small a, I don't know, but I know angle A 70 degrees. Small b, I don't know, but I know angle B 45 degrees. Small c is 8 and angle C we had found it to be 65 degrees. So I replace whatever is known in the given formula. Now I'm going to consider the first part and the last part. A over sine 70 degrees equal to 8 over sine 65 degrees. Cross multiplying, simplifying, I will get A equal to 8 sine 70 degrees over sine 65 degrees, which is equal to 8 decimal to 9 centimeters. So this means that BC will be equal to 8 decimal to 9 centimeters. Now I will use the second and the last part. So B over sine 45 degrees equal to 8 over sine 65 degrees. Cross multiplying and simplifying will give me B equal to 8 sine 45 degrees over sine 65 degrees. So B is equal to 6 decimal to 4 centimeters. Example 2. Solve a triangle ABC in which angle C is 63 degrees, angle A is 34 degrees, and AC is 15 centimeters. So first I label the sides with small letters A, B, and C. Angle B will be 180 degrees minus angle A and angle C. So angle B will be 83 degrees. I write down my formula. Remember, it is always good to write down the formula first so that you can then replace the known values. So here, small a is not known, but angle A is 34 degrees. Small b is 15. Angle B we have just calculated. It is 83 degrees. Small c, I don't know. Angle C is 63 degrees. Now I take the first two. So I have A over sine 34 degrees equal to 15 over sine 83 degrees. Cross multiplying and simplifying, I get A equal to 15 sine 34 degrees over sine 83 degrees. So A is equal to 8 decimal 45 centimeters. Now I take the second and the last part. So 15 over sine 83 degrees equal to C over sine 63 degrees. Cross multiplying and simplifying will give me C equal to 15 sine 63 degrees over sine 83 degrees. But C will be equal to 13 decimal 47 centimeters. Now we move on to case 2, where two sides and one angle are given. Example 3. Find angle B in triangle ABC, given that angle A is 50 degrees, AC is 12 centimeters, and BC is 13.1 centimeters. So again, I will have to write down the formula first. I label my triangle with small letters A, B, and C. I plug in the known values in the formula. Now, I consider the first two. Cross multiply, simplify, I get sine B equal to 12 sine 50 degrees over 13.1. So, now to find angle B, I need to make use of sine inverse of this value. So you evaluate this on your calculator, then you make use of sine inverse to get angle B, which is 44.6 degrees. Example 4. In triangle ABC, angle A is 45 degrees, AB is 18.5 centimeters, and BC is 15.7 centimeters. I need to find the two possible values of angle C. So first, I label my triangle. I write down the formula. I plug in the known values. I need to find angle C. So I make use of the first and last part. Cross multiplying, I get sine C equal to 18.5 sine 45 degrees over 15.7. Now, to find angle C, I will have to find the sine inverse of this angle. But I have been asked to find two possible values. So you will remember that sine of an acute angle is also equal to sine of 180 degrees minus this acute angle. For example, sine of 30 degrees is also equal to sine of 180 degrees minus 30 degrees. That is, sine 30 degrees is equal to sine of 150 degrees. Similarly, sine of 60 degrees will be equal to sine of 120 degrees. So here, when I find sine inverse of this value, I obtain 56.4 degrees. So to obtain the second value of angle C, I will have to subtract 56.4 degrees from 180 degrees. Therefore, angle C, the two possible values will be 56.4 degrees and 123.6 degrees. You now have some exercises to practice on the sine rule. You will notice that in questions 3 to 6, no diagrams have been given. So you need to draw your own triangle. You just need to sketch the triangle to help you to label the sides, and then you apply the formula. You also have some interesting links on the sine rule. I would advise you to visit these links to get additional information on sine rule. So in today's lesson, we have learned about the sine rule. Remember, you have to label your triangle. This is the first step. You label the sides A, B, and C. You write down your formula. You have two different formulae. They are more or less the same. It depends. If you want to find length, you can make use of the first one. If you need to find angle, you can make use of the second one. We can use the sine rule in two different cases. Firstly, when two angles and one side are known. Secondly, when two sides and an angle opposite to the given side are known. So students, we have reached the end of the second lesson on trigonometry. We still have a third video on trigonometry where you will learn about the cosine rule. So until we meet again, it's goodbye.